Hello, everyone. Today, I'll introduce our paper, GeoCol, a geo-distributed cloud storage system with low cost and latency using reinforcement learning. And this paper is the cooperation between University of Virginia, the University of Post and Telecommunications, University of Glasgow. First is the outline of our paper. I will introduce the introduction and the related work. The measurement study shows our measurement for the network and also the main design performance evaluation. Finally, I will conclude this paper. Currently, more and more web applications are deployed on the cloud storage services to provide low latency services to the web application user without the high monetary cost or complexity of owning and operating data centers. Several web servers are deployed geo-distributedly to handle clients' requests for the data objects. For example, when a client sends out the data request, the request is forwarded to the client's nearest web server. The web server then redirects the request to one or more data centers storing the replicas of the requested data object. In order to guarantee the quality of user experience, a web application developer sets a latency requirement to service level objects for data requests. There was many previous work working on these problems. The first category is the request mechanism. They're trying to improve the request mechanisms and then to improve the request performance. However, according to the previous work, they are limited into 2 sub-requests and does not find the optimal number of sub-requests to minimize the latency. Furthermore, they only choose the closest data centers which may not provide the lowest latency. And they didn't consider the time-varying latency feature or the monetary cost. For the second category, it's the data storage type determination. However, for this category, their optimization problem-based methods are for data type determination are not time efficient. The third part is the replica placement. For this related work, they focus on how to minimize the latency or satisfy the latency requirement via data replica placement, and they are using the single request mechanism, which is not optimized. According to our introduction, we know that the goals for the web application on cloud storage are 2 goals. The first one is reduce the request latency. The second one is reduce the monetary cost paid to the cloud service providers. In our method, we propose GeoCol, which is novel in that it further reduces both the request latency and the monetary cost by adaptively determine the number of sub-requests for a request and their destinations and determine the data storage in data centers, along with data type determination using reinforcement learning techniques that can consider complex environments for decision-making in a time-efficient manner. So let's first talk about the measurement study. We first measure the different data objects and from the client to the data center. The client is located in Genie and the data center is located in AWS S3 server. We have the opposition. One is that the high request latency variance even for the same data size of data objects. The second observation is that the request latency is not proportional to the client data center distances. The third one is we tried 3 different machine learning prediction techniques, SVM, LSTM, and SARMA. And finally, we got that SARMA can achieve the best performance in request latency prediction. The first observation is that we tried the simple way for the request splitting, and the request splitting can achieve the best latency performance. The fifth one is that different data objects should be stored in different storage type and data centers. we measured the different number of data requests within the different number of monthly requests and also the distribution. That's why we get how we get the observation 5. So here is the overview of our system. Suppose the structure is that the web application user send a request to web server, and the web server send a request to the cloud storage to retrieve the requested data objects. In GeoCol, there are 3 parts. The first part is network monitor, which monitors the network information, and then as the user network information as the input of the 2 IR agents. The first IR agent is adaptive request split IR agent, which split the request into different number of sub-requests and then determines the destination for each sub-request. For the second reinforcement learning agent, it determines the data objects distribution and determines the data storage type. Here is an example that we show the advantage of the request split. Suppose we have one user and they need to retrieve data from the cloud storage. In the scenario 1, there is only one request, and we can see that there are 3 parts. They are sequentially running in the network, and the latency is like is shown as the length of the line. In scenario 2, we can split the request into 3 sub-requests to 3 different data centers. And in this scenario, the 3 sequentially requested data as we can change it to the parallelly 3 sub-requests, which reduce the latency. Next is about the performance evaluation. We have the experiment setup and the Genie AWS3, and we have the 5 comparison method, and all the pricing policy is used from AWS, and other experiment settings details, please refer to the paper. The performance evaluation, we can see that the left figure shows us the request latency metric, and the GeoCol can achieve the best performance with very lower variance. And the right figure is about the monetary cost. We simulated 12 months, and we can see that GeoCol can achieve the best monetary cost among all the methods. Finally is the conclusion. We have the measurement study, so the insightful observations. Our method, GeoCol, includes adaptive request split reinforcement learning agent method, and the data storage reinforcement method, which is used by each data center to determine the storage destination and the storage type. The third one is the trace-driven experiment shows that GeoCol outperforms other comparison methods. And finally, we will further investigate how to extend the monetary cost minimization on virtual machine requests and migration in cloud data centers. Yeah, thank you.